All right. I'm not sure if people have concerns or questions related to what we've covered so far. So the last time we met, I believe we started our discussion of image encoding. So I'm not sure if that was clear. If it was clear, then we're going to continue off from where we left off. I believe there's still a few more things to chat about, things related to image encoding, but we did get to a stage where we realized actually that color encoding plays a crucial role in helping us represent so-called images, right?
Sir,
The average image is pretty much made up of pixels, and the pixels are composed of nothing more than varying intensities of colors. Yes, sir.
uh, is all color encodings, or is color encoding all in Unicode, or
Unicode.
like?
Unicode has to do with textual content.
Oh,
That's
right,
something
right,
completely
right, right.
different.
I missed the point then.
Yeah. Anyway, so right, and so we got to a stage of that, I guess. Anyway, so something worth mentioning here, something related to, I guess, our discussion of so-called files, is this whole notion of metadata. It turns out, right, that your typical image file, right, will, in addition to the bits that make up the image, right, there's additional information that is normally encoded within the file itself, so-called metadata. And a conservative estimate puts the metadata at roughly 16% of the total size of the file. Right, so this metadata will typically include important information like so this screen grab here on the right just gives you an idea of the metadata itself. So important information like where the image was taken, right? So the geolocation, the GPS coordinates associated with the photo itself, and this is something that a number of people don't really realize, right? That the average device that you use to take a photo will sometimes implicitly keep track of where the photo was taken. Now, for privacy concerns, some people would feel uncomfortable about that. In certain instances, though, that becomes extremely important, right? Especially in this day and age where your average person will pretty much take hundreds, if not thousands of photos, right? At any given point in time. I mean, I do this a lot myself. When I travel or when I visit a place that I have not visited before, I take advantage of the fact that I normally have a number of devices with me, but also so storage space has become extremely cheap, right? So typically my digital camera, the one I mostly use, would typically have a 64 GB SD card slotted in there, right? That's more than enough for me to take as many photos as I want, right? So imagine a situation where, if you remember yesterday, for instance, we looked at some weird example. I don't know if some weird example of this file here. So let's assume you have 2.4 megabytes, right? So 2.5 megabytes rather. 2.5 megabytes of your typical, of course, I mean, your typical high resolution image will probably be slightly larger. My digital camera, I think, takes your average file size is usually in the region of about 6 megabytes. But let's work with, let's say, 2 megabytes, right? 2.5 megabytes. You realize and appreciate the fact that if somebody has a 64 GB SD card, right? 64 GB SD card. Oh, come on, 64 GB SD card, and the average photo that they're taking is let's say 2.5 megabytes. What you immediately realize here is that the total number of photos, right, that person can actually store on that SD card is huge, right? So, I mean, all I would have to do is just convert the 64 into 1024 here, then divide it by 2.5. So my 64 GB SD card, and of course, I mean, the SD cards of sizes 128 GB have become insanely cheap now. You can pretty much pick it up from your average electronics store at a relatively low cost. I think it should be less than 500 kwacha now. But anyway, so you realize that I'll be able to take about 26,000 photos if I wanted to, right? Once I'm done, obviously I'll sync them to some free cloud storage service like Google Photos, for instance, right? So, but the key thing here is we're talking about metadata, right? So geolocation, and that geolocation thing is extremely important because when you're using tools like, think about this for a second, when you're using tools like, or services like Google Photos, and let's say you visit some place, maybe the Lusaka Museum, and you took some nice photos there. I hope you did visit, by the way. Very few people have the time to create or to properly tag the photos that they take, right? So where you associate the location, where was this photo taken? What is the title? What title are you going to give to the photo? What people would rather do, people become so lazy these days, is you take advantage of these intelligent tools that have been implemented that will automatically figure out where the photo was taken and then properly curate your photos by location in some instances. Of course, I mean, the most you'd have to do is create some sort of album. I don't know if you've done this in Google Photos. I do this a lot myself. So it could be an album based on location or something. But so the geolocation is just one of many metadata elements that are normally associated with the device. You'll find interesting things like the manufacturer, right? The manufacturer of the device that was used to take the photo, right? I guess there's usually a lot more, right? Information, but the key takeaway point here is that in addition to the bits, the ones and zeros that are used to represent the actual image, there's additional bits that are used to represent the meta information, the descriptive information associated with the image itself, right? And again, I mean, we touched on this idea of the fact that typically your raw image file will be extremely large. And so to ensure that you don't run out of space, your average device manufacturer will implicitly compress the raw image file. So that would be your .dng file. So typically this would be compressed either in PNG or JPEG, for instance, right? And again, this notion of compression is also applied by your average cloud-based service provider, right? So tools like Google Photos, for instance, will give you the option to compress your original images, right? Because remember, even though your device will automatically compress or will by default not enable you to store digital negatives, the resulting file, which is usually a PNG file, the resulting file is also large, right? If you look at this PNG file, for instance, you notice that it's 27 megabytes in size. It's not sustainable for a cloud service provider to give you free space and allow you to upload these large files, right? There are millions of people using this service.
Sir.
Yes.
Sir.
Yes,
how
sir.
true is it that photos begin to lose quality as soon as they are posted? If they've been posted for a long time and been shared too many times.
No, that's not true. Doesn't make sense actually. If there's even some semblance of truth in that, I mean, I don't know where you got that information from. It would be nice if you could share a link or something to a resource that you were reading. It's the first time I'm hearing about that.
Since I got it from like I was looking at videos on YouTube, and then since videos are a combination of sound and images, and then as I was looking at how many times the video has been shared and how long it's been there, the quality is not as it was at the time it was made.
No, that's
So,
not true. The quality remains the same. I mean, you're probably viewing YouTube when you are connected to maybe I guess an internet service provider which was providing you with perhaps a relatively low connection rate or something. Because what happens with YouTube when you're watching is the quality of the video that is presented to you in part takes into account the quality of the connection, right? So how fast your connection is. If it's a slow connection, then the resolution that will be sent through to the video resolution that will be sent through to your device will be of low quality, right? So usually like 240p or something or 144p. So it has nothing to do with sharing. When you're sharing something, you're making a duplicate of the copy. So it doesn't have, so if I wanted to share these slides, I'm not going to share the slides that I have right now. I will make a copy of the slide. I'll still keep the original slide. So I don't see how the quality would be affected in that case. Yeah.
I understand, sir. Right.
Yeah. Anyways, so this notion of compression, right? So I was talking about services like Google Photos will ask you to do that, which is why once you upload photos there and you're using the, I guess the free tier of Google Photos, your photos will be, they'll lose the quality, they'll be compressed further. So you probably end up with a JPEG file, which is, like in this case, it's just an example. If you notice, the digital negative is about 32 megabytes in size, and then the PNG file derived from the digital negative is about 27 megabytes in size. And then, lo and behold, the JPEG file is 5 megabytes in size, right? So you're dumbing it down further. And in fact, this notion of compression of images manifests itself in web applications or websites, for instance. These images that you see on websites like Unza, though typically, unless if it's a person who is not knowledgeable in web development, the images that you see on these websites are of low quality. So usually be JPEG files or D files or something, or G files, right? Rarely will people use PNG files, unless if it's one of those websites where the aesthetics are so important that you want to use high quality images. Why? Why do you want to use low quality images? Well, you want the average user accessing your site to gain access to the content in the shortest possible period of time. The larger the files that you're associating with the website, the longer it's going to take for them to consume the content, right? So all we're saying, right, is that these things that we're seeing here, all of these images, and you can pretty much check these things, by the way. If we were to look at the sizes of these images, like, I don't know if there's a background image here, hopefully there is going to be a background image. I mean, it's a PNG file, quite right, but obviously the resolution has probably been dumbed down slightly, right? Right, so what we're saying is usually these are low resolution files. If you were to put this thing here, you notice that it's a relatively small file, right? Not so large. It's just 300 kilobytes, which is what you want, right? Because when the average person is accessing the website, so if I go into the UNZA website, what is happening once I access a particular file or page, rather, HTML page, is that thing is sent to my computer, right? So from wherever this UNZA website is being hosted, whatever server, that file, the page that I'm requesting is going to have to be sent through to my computer, including all the assets, right? So the images, and if there are sound files or videos, they all have to be, the entire payload has to be sent through on my side. Now, if what's being sent through to my side is large in size, it's going to take insanely longer, right, to get to me, especially if I have a slow connection, right? So things to think about here.
So,
yes.
I'm sorry, but I have another question.
Okay.
Yes. I download my videos and my images using Internet Download Manager on Windows, right? And then videos that are uploaded on Google Drive by, let's say, Mr. Mwalimu, are very big in size, like 200 megabytes. And then when I download them using Integrated Download Manager or Internet Download Manager, it goes down to 24 megabytes. So does that mean the download manager compresses everything, or
Yeah, I don't know. I find it hard to believe that a video that is maybe 200 megabytes in size will suddenly change the size to 24 megabytes. That's a tenfold reduction here. That's very strange. I
That's what
mean, if you were
that
to from 200 megabytes to 24 megabytes, I don't know.
yes,
It would be
it was
nice
compressed like that.
if you could share those things with us so that we could see what typically happens. But the only speculation I have here is that perhaps this tool that you're using will implicitly compress or it will change the resolution of the video so that you download it at a much faster rate. And we talk about compression, video compression just now. I mean, it's tied to this notion of lossy compression. So there's lossless compression and lossy compression, right? So you compromise when you're compressing a video file, when you're changing the resolution of the video, what you're doing is you're compromising, you're trying to strike a compromise between the amount of space that the video is ultimately going to occupy and the quality, right? But still, I mean, dumbing it down to from 200 to, I don't know, maybe. But anyway, it could be that to answer your question, if indeed the reduction is a tenfold reduction, then it's likely that the application you're using does the compression for you. It's quite strange because I guess your average application is supposed to allow you to specify whether you want to dumb down the resolution or something.
No, it just it makes the downloads faster. Like all the downloads I get using the same software makes go faster. And when
Yeah, but so the faster rate is tied to this idea I just talked about, where you're compromising quality and space, right? The space argument is the same as the speed, right? Because remember, ultimately, if you look at speed is a derivation of size and time. Your download is going to be much faster if the payload that you're downloading is much smaller, which is why I'm saying it's likely that your application implicitly reduces or changes the quality, alters the quality of the original file so that you download it at a much faster rate. But I don't know. I've not used the tool you're talking about. And that would be interesting if it does reduce it from 200 to 24 something. If you could share links to the original file and what you've think, maybe send it to the mailing, that would be nice so that we can learn from you. Maybe people would start using the same download manager you use anyways.
It's a cracked version, sir. So
okay.
I would share it physically more than.
We can always share the link so that people just know the application you're talking about anyways. All right. So, right. Again, as with most files that we've discussed, like textual content or images, what you can do, textual content, what you can do if you're curious to see the representation of your image file is you can use your one of popular hex editors. I like Octeta myself, just so you gain a sense of how a computer would probably view the file. And you notice that similar to textual content, right? So I just opened up Octeta here. Similar to textual content, the representation of the image file is pretty much going to be the same, right? Ones and zeros. Again, trying to highlight the fact that as far as a computer is concerned, it doesn't matter whether it's a text file, it's an image file. If you could please mute your microphone, whoever you are, that would be nice. It doesn't matter what sort of, yeah, I don't know who that is, but. Yeah, that's platform. It doesn't matter what sort of data you're looking at. The representation will be ones and zeros, right? Ones and zeros, which is why, again, this argument comes up. It's going to come up over and over again. Application software is tremendously important because application software is going to implicitly tell the computer how the data is supposed to be rendered, whatever data the user is interested in consuming. In this case, once I do know that the data I want to consume is an image file, perhaps by way of the file extension, PNG, JPEG, GIF or GIF, or TIFF file, or if it doesn't have an extension and I know it's an image file, then I'll know that I'll need to use I'll need to use an application that is able to render files for me. So GIMP, WinView, Photoshop, or whatever other fancy application you feel like using, right? All right, so hopefully that kind of makes sense here. So this brings us to our discussion of video encoding, essentially, right? So it turns out that the things we perceive as video or moving pictures, they call it, or as they used to call it, is nothing more than a combination of two different types of data formats or data, right? So you are combining sound and images, essentially. But the interesting thing about how the images are incorporated into moving picture is that what happens with video effectively is you have a whole bunch of images that are presented to you in rapid succession, right? And so your eyes are fooled into thinking that it's actually a continuous moving picture or motion picture. When in actual fact, it's just nothing more than a series of images that are presented to you in rapid succession. Now, this idea of images being presented to you in rapid succession is associated with so-called frame rate, right? So the rate at which these images are presented to you in rapid succession is a frame rate. So the size, the number of frames presented to you in a given second is what's called the frame rate. These days, the images that you see on the images associated with videos on YouTube or these other things you watch on Facebook or something, by default associated with a frame rate of about 25, in certain instances 30. I do believe most of the gadgets I use, like my GoPro, I think by default uses 30 frames per second, or a frame rate of 30, I think. So that's 30 frames per second. But really, this 5-minute frame rate difference is something that you wouldn't really notice unless if you understand how video is encoded, essentially, right? Right. So you notice here, respective of the sort of quality associated with a video, let's say on YouTube, this what you're seeing here on the screenshot is it's this video here, right? And so what we did was we decided to, this was taken last year, I think, but what we did was we decided to, oh wow, sorry about that. What we did was we got, in this example, what we did was we went to this video, right? This video was recorded in I guess in 1080p or something, which is high definition, extremely large in size. But once uploaded to YouTube, and I think one of you just asked this question, but once uploaded to YouTube, what YouTube does is it takes into account the fact that there's a number of users that might be interested in consuming video on their platform, right? And those users will probably have different types of devices. They will have varying connection rates to the internet. And so the video that you upload to YouTube is transcoded into these different formats. And this is what you see when you click this cog sign here, the cog sign. By default, YouTube will give you a quality that matches your connection rate. So if you look at Lighton's connection rate right now, I'm connected to this stupid Zamtel connection here. Not very fast, not the fastest of connections. But because my connection is not that fast, by default, if you notice, by default, I'm using a 360p resolution, right? But it turns out that the original image, or it turns out that for this particular video, right? This was uploaded by me. I actually recorded it in 4K. It was meant to be an example, right? I could view this in 4K if I want to. In fact, my connection is unlimited here. I could view it in 4K, but this 1 minute, 39 second long video, when viewed in 4K, would probably be rendered at a much slower rate. Why? Because it's a large payload. So if I switch this and I try to watch it, you notice this red progress bar here that shows you the progress of the playback. Well, it's, in fact, I'm guessing it's probably going to affect even the connection to Google Meet. I don't know if you're still there, right? Because I'm attempting to view this. Are you still there?
Yes, sir, we're here.
Yeah, I'm attempting to view this in 4K, which is insane, really. But maybe we can just go back to maybe high definition, 1080p, I guess, might be okay. But this is the thing here, right? So things are transcoded into these different formats because YouTube knows that there are people that have low connections. No, quality is quite good actually in 1080p. There are people that might have insanely slow connections. And in fact, there are people that might explicitly want to watch videos at a resolution. Could you please switch off your microphone? There's a bit of echo. Except not me. I don't know what's happening. Thank you. Anyways, so frames per second, right? What we're talking about has nothing to do with frames per second, but this thing was just trying to showcase the fact that irrespective of the type of resolution here, the frames per second are the same, it remains consistent because it's the same video, effectively. Right. All right. So in this example, I guess what I was attempting to do here was to showcase the fact that your typical video, right, is actually composed of images, right? And so I took advantage of an application called FFmpeg. And so we used FFmpeg here to unroll the frames or the different images associated with this video itself. I wonder if we can, I don't know, maybe we might as well just do this, I guess. I don't know. We could, I suppose. There's a 20, still a bit of time here. But so let's say we wanted to just showcase, let me just showcase this. So what I'm going to do is I'm going to pull, I don't know what this is, but 2 likes. Okay, that's fine. I wonder who unliked this, but probably some student who failed or something. But let's say maybe just the video is not descriptive, just joking. Let's say we wanted to, let's do this. I'm just going to say examples or something. I'm just going to go to examples here. So let's say we want to pull, oh crap, I guess. Oh yeah. Let's say we want to check the different types of, these are the different types of resolutions, right? So I'm using FFmpeg to check to say what sort of resolutions are available to me for this particular video. Let's say I'm interested in downloading this, and I think I'm going to use this different terminal command, which has a somewhat smaller font so that you can see here. I think I saw something to do with, I don't know if you can see these file sizes also, right? These are extremely important. You notice the different resolutions. So if I decide to download audio only, the file sizes are much smaller. This is 559 kilobytes, right? This is 1 megabyte, 1.5 megabyte. But if you go to the, I guess, where is the 4K here? I don't know. No, 4K is not here. I can't see. Oh, it could be this, I guess. You notice that this is 199 megabytes in size, right? So the higher the resolution, the higher the file or something. But let's say I wanted to download, I'm just going to download, for this particular example, I'm just going to download 720p or something, I guess. That would be 247. I guess 247 or something. Let's say I want to download that. Just pull that thing, right? Once I pull it, I want to showcase the fact that this thing here, I want to showcase the fact that this thing here, and it's taking slightly longer because my connection is very slow, very horrible connection. This so-called Zamtel. Is it Zamnet or Zamtel? So I just want to showcase this example on the slide here to show you that that in fact, once you unroll these images, once you feed this video to a utility like FFmpeg to unroll the video itself, you end up with with a series of, oh my God, series of, where was that? Series of, I do apologize for that. I think I may have, beautiful, this is it, Lenovo. I just create ICT 1110. Lenovo to ICT 11. All right, I hope this is the one. Yeah, I think it is the one. I was expecting it to be in MP4. Anyways, I hope FFmpeg will be able to process this. But here's the thing, right? If we are to, I hope this is going to be unrolled. If we unroll this, and I hope it doesn't take long, we should be able to come up with a series of images, right? Hope this is working. A series of images, and these are the ones, these are the things that are being unrolled here, by the way. Because this thing, if this thing is, if you think about it, this thing is 1 minute, 89 seconds. Now, if based on what we saw here, we're saying this image, this video is encoded using 30 frames per second. Each second is associated with 30 images. So the number of images here, we can easily, 1 minute 39 seconds is nothing more than 60 seconds plus 39, right? So these are 99 seconds. If we're saying each second is equal to, each second has 30 frames, what we expect is approximately 99 times 30 images, right? So 2,970 images. This is why this thing that you're seeing here, I'm done now, by the way. This thing that you're seeing here, these frames here, you see these frames here? These are probably like, anyway, it's somewhat closer to 2,900 frames. If we were to count these, right, I'm just going to just frames or something, JPG, and we count these, I guess, it's like 2,900 somewhere there. I don't know if you can see this number here. And true to that, right, if I go in here, right, and it's kind of check, if I go in here and just check the images, you will notice that each one of these images, from the beginning image, is associated with the actual video. If you are paying attention to the video on YouTube, this video here, you notice that the very beginning of the video has this image you're seeing here, this JPEG image. And in fact, as I'm moving image by image, you notice that eventually you start noticing that this is changing. I'm just shifting through the different images. Pay particular attention to what's in the title here. I'll start with the first one, right? Frame number 1, 0001. Do you see this? 00001, 00002. As I'm moving, you notice that it's like you're watching a video, right? But these are just images. So this is what you see, actually. And I'm moving at a much faster rate now, I guess, so that you see, this is what you see, actually, right? Oh, it's video. Well, I don't know. It's just images, right? Just images. All 2,900 plus of them, right? And combining what you're seeing here with sound is, oh, I'm watching a movie. Good luck doing that. Is this making sense, right?
Yes, sir.
Oh, good stuff. So it turns out that this so-called video data here is typically encoded using standardized formats, right? These are called codecs, right? And I'm sure you've come across these things. Back in the day, it used to be a problem that you couldn't watch certain file formats. So you needed a particular type of application software to do that, especially on Windows. I don't know if things have changed now. But with tools or with applications such as VLC, you have inbuilt codecs for the most popular video encoding or video codecs, right? So you don't have to worry about downloading a codec or something. So they come in different types, right? So the popular MKV form, MKV.mkv, right? Matroska, or indeed MPEG-4, right? MP4. You've seen these. At some stage, 3GP was very popular on mobile devices. I think that thing has gone away to a certain extent, but probably still there. So formats like GIF or GIF, depending on where you're coming from anyway, where you create an animation without sound, right? I'm sure you've seen these things. Hopefully you have. So depending on the encoding used to create this video file, you probably need a dedicated codec, right, to decode the video format so that you're able to view that format. And what you're doing really with the codec is just, the codec is nothing more than a piece of software that conforms to the specification associated with the video that you want to play back, right? Right. So again, I mean, in terms of resolutions, the resolution is mostly associated with quality of video, right? And it turns out that these numbers that you tend to see on YouTube, for instance, they'll say it's a 144p resolution, 240p resolution. This does nothing but spell out the horizontal and the vertical width associated with the video, or rather implicitly the total number of pixels that are used to represent the video, right? So a 1080p resolution, for instance, would simply mean it's a 1920 by 1080 resolution. And interesting enough, this only applies to, for this particular example, this applies to, I guess, a screen or a video that has a 16:9 aspect ratio or something. And in fact, if you dumb this down, this number here, what you'll notice, right, if you have like a, it's mostly for newer videos on YouTube, it's 16:9 aspect ratio. This is how your devices are designed, by the way, your mobile devices, right? So the width, the larger portion of the device is associated with 16, and then the height, depending on how your orientation of the device here, the height is a 9, right? So if it's in landscape view, that's a perfect 16:9 ratio. If you dumb this down, if you were to divide, if you were to look at this 1080p here, let's say 16:9, it's 1080p divided by 9, I guess, I don't know. So 120. So if we divide, I guess, I don't know, 120, we should be able to get 16, right? So these all conform to a 16:9 aspect ratio. And in fact, an interesting way of trying to figure out what aspect ratio is used, I hope this will work here, maybe not, is to check what we unrolled just now, these images. I'll just open one of them, right? And then just check the resolution here. Okay, this is I just downloaded it because it was 720p. So it's 1280 by 720. And this also conforms to the 16:9 aspect ratio. If you think about this, I'm just going to say 720 divided by 9 here, divided by 80. If I divide 1280 by 80, I should be able to get 16, right? So 16:9 aspect ratio, essentially. Right, so nothing complex about how images are kind of rendered. Just be aware here that when you're downloading these different resolutions from YouTube, you come to YouTube and you tell YouTube, I want to view this thing using a 144p resolution. What you're doing here is you're telling YouTube you want to view this at a significantly lower resolution. You're compromising quality over size, maybe because you're obsessed with how much money you're spending online or something. I don't know. All right, I mean, so we've already talked about some of these things here. I just showcased an example. If you, maybe what I will do is I will share these unrolled images, right? All these 2,900 images, although this is going to be quite, I don't know how much size we're talking about here, but it shouldn't be that much, I guess. It's just 86 megabytes. I will share this so that you can look at what we've unrolled, the images we've unrolled here. I don't know what you're going to do with these, but you can play around with these and just try and see, right? And a question to, maybe something else to think about here is how people come up with these funny techniques where you can come up with a heuristic or an algorithm that will skip certain portions of the video because they are the same, so that you cut down on the amount of space, right? So if you look at some of these images, this is 1090, the 1092nd image, but you notice if I move to the next one, it's exactly the same, right? Exactly the same. There's no difference at all, right? So you can design an algorithm that compresses the image by just checking, are there any images, right, that are more or less the same. Maybe you can shift them, you can remove them from there, right, because they're useless, right? So you take note of just the minor, the subtle differences in the orientation of the images or something. Anyway, I should share these or something, maybe I will, or something. Right, of course, I mean, so we're saying high resolutions obviously be associated with higher file sizes, because a higher resolution, think of this number here, a higher resolution means more pixels. More pixels mean large sizes, right, because you're occupying more space. Now, always like having fun asking people what their preferences are when they are consuming video online. By people, I mean you, right? And this slide is almost there almost every year, but we started having it last year anyway, where I always try and remind people that if you know what you're doing, the reason why you'd consume a video in a particular resolution on a video platform, like a video sharing platform like YouTube, is perhaps due to cost implications, right? So if you buy a bundle, right? If you buy maybe a 1 GB bundle, and you've set let's say a threshold of 1 GB per day, you don't want to exceed 1 GB per day. The last thing you should be doing as a normal user who is knowledgeable is consuming video using a much higher resolution, like high definition. Why would you do that, right? Why would you want to watch this 1 minute 32 second long video in 4K, knowing full well that this 4K video here means you consuming 199 megabytes of data. You understand this? 199 megabytes of data is 19% of your daily 1 GB allocation, assuming you have the 1 GB daily allocation. Why not instead consume a much lower resolution? That's what I would do myself anyway. I mean, of course, I'm not you, but this is what I would do myself, right? I would come here and I would tell myself, you know what, I'm just going to, I check YouTube and I see, oh, let's see, 144p it's a low quality, it's pathetic quality, but I will only use 988 kilobytes, right? Which is, I mean, if you are happy with the thing, if you're happy with the quality, it is pathetic, really. Nobody watches in 144p anymore. Maybe they are there, but if you're happy with 144p, then you go there because you know that 144p, observe, 144p here is going to enable you. Look at the quality. It's not that nice, right? Look at the 10th second here. 10th second, if you notice here, and compare it with 4K on the 10th second. Are we still in 4K here? No, this is 144p still. If we go in, let's not go 4K, but let's go to 1080 high definition, 1080p, and we go to the 10th second. What you notice is there's a really significant difference, right, in the quality. Observe what's happening on the 10th second. Okay, not the 10th second, but maybe we'll go to wait a minute. This is the 10th second. We can go to the 10th second here. Observe what's happening on the 10th second, right? Compare this, what you're seeing here, with what you're seeing here. 144p, 1080p, right? And you can, I mean, we can do a really nice comparison where you get to look at all the different resolutions. Let's say 360p, which is what I use myself. I've discovered from my personal, I mean, this is a subjective view here, but 360p is a perfect compromise between amount of money I spend on data, especially if I'm using data bundles, and the quality. It turns out for me, for most of the videos that I consume, 360p is perfect, right? I don't spend that much on bundles, right? When I'm downloading the payload, observe this, 360p, look at this MP4, 1.49 megabytes, right? Let's do a comparison here. 144p, 240p, 360p. And then we'll jump to high definition. We'll put 170p and then 1080p. Observe, right? File sizes 144p is just pick this, which is 884. I guess I just copied this. I guess I don't know. Oh, come on, really? Right? And let's say this size is going to be megabytes anyway. So we'll convert this because this is in kilobytes to megabytes. There we go. And then we'll do a round off so that this is like Mr. Mwalimu has taught us. Do that. And then we go to 240p, which is here. We'll just pick the largest, which is 2.14 megabytes. 2.14 megabytes. We go to 360p. 360p is, we'll go for 4.49 megabytes. 720p, we'll go for the MP4 one, which is 19.95 megabytes. High definition, 1080p, which is here, we'll go for 46.44 megabytes. And so you sit there, right? And you should be doing this. This is why we're doing this, right? You sit there and you must ask yourself, so what am I going to do? Do I want to watch this video like this and spend less because I'll be consuming 0.86 megabytes? Or do I want to watch it like this, right? In which case, this is like 720, or 1080p. In which case, I would have to spend the equivalent money associated with 46 megabytes of data, right? So different ways of looking at this. It's all centered around preference because this is subjective, right? So you take into account things like the cost. Time is going to take. The larger the payload, the more time it will take. If I am to download, if I am to want to benchmark the download here of this 2K file, which is 199 megabytes, it will take much longer, right? Look at this. I'm just going to showcase something to you. I guess I'm just going to say, observe. So I'm going to come here and I say, I want to download this same video, right? Check the throughput. I'm going to download this 1080, the 4K video, which is this 313. Just going to come here. Just going to say 313 here. I guess we can end it there because I have another class. I'm going to download this, right? Observe what's happening here. Oh, it's already downloaded. Oh, shoot. I'll rename Lenovo to Thunderbird Lenovo to this. Because I'm attempting to download it in a location which already has that file. But observe what happens here, right? Observe what happens, people. If I try to download this, check the throughput, right? You notice what's happening? ETA is telling me it's going to take roughly 2 minutes or something, right? 4 minutes now. But it's taking longer, right? That's the key thing here. But on the other hand, if I decide to download the same file, yeah, I guess the same file, but with a different resolution, let's say 360p, which is what I love myself. I really love, so it's ID 134. I'll come here and I'll tell this thing, I want to download 134, right? I'll come here and say 134. I'll be able to consume this much faster, right? It's a race here, race against 4K and 320p. I've already done 20% here. I'm at 7% here, right? So take your pick, choose your poison. If you have a lot of money, I guess you don't have to worry, right? If you're not concerned with how much money you're going to spend on data, you don't have to worry about these resolutions, right? If you're obsessed with quality, if you have a problem with your eyes and you want things that are aesthetically pleasing, depending on the type of video you're watching anyway, you want to take into account quality, right? So these are things to think about, right? And again, I was trying to latch on to some of the things, the ideas we've already discussed here, throughput and space and all those fancy things here.
Sir.
Yes, sir.
So when checking out an image, all metadata elements are taken into account, right? In image encoding.
What do you mean when checking out the image though?
Or in encoding, image
Yes.
encoding. All metadata elements are taken into account. The size, the time, even the location, right?
Well, what do you mean by they're taken into account though?
If I'm told to describe metadata associated with an image, it means I'm supposed to take in the time, the location, and the size. Unless there's something else I'm missing, sir, apart from those.
Yeah, I mean, there's a whole bunch of other metadata elements, right? The dimensions of the image, the DPI, the dots per inch associated with the image. So yes, I mean, all those in addition to others. But the key thing here is some of the things you've just highlighted here, the fact that the normal metadata elements that we spoke about associated with files, like the size, the file name, those are implicitly already a part of the image file, because an image file is nothing more than a file. It's a regular file, right? So yeah, all of those things are taken into account. Although there's a difference here between the metadata we just spoke about here and the file metadata, right? So things like the geolocation of the file, these are embedded within the file itself. Right?
Okay,
the file name and the file size, these are typically inferred by the operating system.
Right. But to abstract it all, it's just time, size, and location, right? Time, size, and location, right?
But what do you mean by to abstract it all?
If I'm looking for the same, to abstract, like to remove the bandwidth or the width and all that, the main three things that I would mostly look at are size, time, and location, right?
No, but it depends on what exactly you're interested in. I mean, again, that's contextual, right? I mean, perhaps you would be interested in those things. Some people would not be interested in the location. And in fact, the location element is optional, because you can tell your device not to capture the location. This is a common feature in smartphones. So just go to the application that you use to take those photos and go to the settings. The settings will allow you to switch off tracking of the location for previous reasons, obviously. Right, so deciding, I don't know why you would want to decide which metadata elements to take into account, but it's contextual. It depends on what exactly you're interested in. But the key thing is that there's a whole bunch of metadata elements associated with images, right? A whole bunch of them, actually. And this 4K is still downloading, but we're already done with these guys here. So if I use, let's see if I think, and I check the metadata elements here, you notice that this thing does not follow the specification. That's fine. I'll check something else. It's not properly encoded. Right? I mean, so all of these are metadata elements associated with an image. So I don't know why you'd want to cherry pick, but in case you cherry pick, it's contextual. You'd have to decide on why you're doing that. But all of these things here that you're seeing here, X resolution, the orientation, the model of the device that I was using, the manufacturer of the device, it's all metadata elements that are embedded within this file, right? All these, the timestamp when this file was created, and these are things that will normally get people in trouble, right? You're caught, right? Or you're a suspect, and you start lying. Oh no, me. They say, well, but we found this image. It was shared in the location where maybe this person, sorry for this example, this person was attacked or killed or something, right? How do you explain that? You know, we can see that you shared this image and it was taken right there at this time, right? You were there and you're lying. But anyway, so these are all different, metadata elements, pretty cool. You can design applications that actually ingest this metadata and then do some fancy things or something, right? This is what smart people do out there. I guess I'm going to have to suggest that we pause things right here. Most of these I've already spoken about here. And then I'm going to, so similar to text and images, you can actually use your popular hex editor to see exactly how a video is perceived by a computer, and you'll be surprised. It's still going to be perceived as ones and zeros because the computer doesn't care, right? It's still ones and zeros. Only you care, right? So I'm going to pause here for a while, and I'm going to have to suggest that we continue or we wrap up this conversation with our discussion of sound and compression tomorrow. I do believe we have class tomorrow. I will endeavor to, I will make it tomorrow. Cancelled all my appointments. So I'll see you tomorrow. Unless if there are any questions, I have a few minutes before I transition to my other class. All right. If there are no questions, then see you tomorrow. Thank you, and enjoy the rest of your day.
Was the lad who was caught cheating sound? Guys, what's happening? What's happening, guys?
Thoma. Oh, why chile?
Boy, boy.
Nza kupeza pamene obwanje.
Pale boy, ngari boy vende dai.
And then we're counseling wankom guys, or Isaka.
Bakansolinga.
Hey, oi, it 10:20.
Hey.
So naona group naona ati he won't be able to make it. He's attending a meeting.
Not a funeral this time.
This time so nothing.
Oh, maybe that guy should boy.
Right, zanpeza mame.
Hey, what's in mind? Hey, Daka boy. Advance, bezo cheating our step of one.
Padre kamba guys boy. Elas que se recordei van.
Bloody.
I can't go kamba change it in.
What's the little good boy?
Ni padre boy. If you see the assignment. If you see the assignment, right?
Series are my chosen pesa, is it?
That's your padre boy.
Okay, chosen pesa boy.
Yep.